Boy, it sure is warm in here. I hope this ice water helps cool me off.
I wish I knew what to do to keep that car parked in my stall cool. The lady that owns it's pretty upset because it overheats so easily.
Well, Brian, I'm not really busy right now. Maybe I can take a look at it and help you out a little.
I'd sure appreciate it, Russ. The engine should be cooled off enough now to work on. It's probably just the thermostat anyway.
Not so fast, Brian. There are a lot more things that can cause a car to overheat besides the thermostat. First of all, do you really understand how engines generate heat and how the cooling system gets rid of it to maintain the best temperature range?
Well, not really.
Okay. First, an engine gets its power from the heat energy caused by the burning of the air-fuel mixture in the combustion chambers. The more powerful the engine, the more heat it's going to generate. In addition, only about 1/3 of the heat generated by combustion is converted into power. Another third finds its way out the exhaust system unused. The remaining third is the part that must be regulated by the cooling system. Today's engines are designed to effectively control exhaust emissions, particularly at idle, where the emission problem is greatest. By using a lean mixture and retarded ignition timing at idle, more of the fuel is burned in the lower part of the power stroke. Naturally, more heat goes out through the exhaust system and subjects the entire exhaust port area to higher temperatures as it does. The remainder of the unused heat is transferred to the cylinder walls and the surrounding engine block area, which creates even higher engine temperatures. In addition to normal combustion, the load on many engines is increased by the rising popularity of boats and recreational vehicles and the use of cars to tow them. More power is required to handle these loads, and more power means only one thing: more heat. Air conditioning keeps the driver cool, but sure doesn't do much for the engine's temperature. Even though the load required to drive the compressor is slight, it still adds to raising the engine heat load. Right now, let's talk cooling systems. If there was no cooling system, the heat from normal combustion would be great enough to melt some of the engine parts. Actually, the cooling system could be more accurately called a temperature regulating system. The cooling system is designed to make sure the engine doesn't run too hot. However, it also makes sure that it doesn't run too cool. Temperature regulation is very important during warm-up. Here's why. The combustion chamber and the surrounding area heats up very quickly while the rest of the engine remains cold. So the first job of the cooling system is to equalize these temperature differences. Fast engine warm-up ensures better combustion during warm-up and reduces combustion blow-by to help control emissions. It also improves cold engine lubrication, which minimizes wear and distortion of engine parts. With the thermostat closed, the coolant is recirculated through the engine through a coolant bypass without going through the radiator. The coolant carries heat from the hot areas to the cool areas to promote fast warm-up and uniform block temperatures. And when coolant temperature reaches the rating of the thermostat begins to open. With the thermostat open, the coolant flows through the radiator before returning to the block. As the coolant flows through the radiator, the coolant dissipates heat to the air rushing through the radiator fins and around the radiator core, and the desired operating temperature is maintained. Now, earlier, we talked about things that put a load on the engine to generate more heat. However, there are a couple of items that put a load on the radiator and therefore on the entire cooling system. The air conditioning condenser is located directly in front of the radiator. This does two things. At low speeds, the air going through the condenser warms up as much as 40 degrees and restricts airflow through the radiator. This increases the coolant temperature through the radiator when the air conditioning is working. The oil cooler for the transmission is located in the bottom of the radiator and is the first place the coolant picks up heat. Now, although it places additional heat load on the cooling system, the oil cooler is necessary to prevent oil deterioration from excess heat.
I'd like to add my 2 cents worth right here. With the exception of the trailer towing package, which the owner must order, each car is built automatically with a cooling system that is designed to handle any additional heat loads that are caused by optional equipment ordered by the buyer.
You're absolutely right, Tech. Brian, I think that by now you have a pretty basic idea of how heat is generated and how the cooling system regulates engine temperature. Now, let's take a good look at the components in detail to see how they operate and how to check them to make sure they're working right. First of all, let's talk about the coolant. There are a lot of things that can affect the coolant, and in turn affect the efficiency of the cooling system. Under extreme conditions, hot or cold, plain water does not make a very good coolant for today's engines. It doesn't take much for water to boil, 212 degrees, or for it to freeze, 32 degrees. Another drawback is that water promotes rust, and the minerals found in water from certain localities can cause corrosion. By adding ethylene glycol type antifreeze to the water, you raise the boiling point and lower the freezing point to make it a better coolant. This type of antifreeze also contains inhibitors and an anti-foamant to retard rust and corrosion and prevent foaming during circulation.
Isn't that what's known as permanent antifreeze?
It's permanent only in name, Brian. It probably could more correctly be called four-season antifreeze, which means it can be left in the cooling system year-round. However, I wouldn't recommend leaving the antifreeze in the system any longer than 1 full year. After a while, the anti-rust inhibitors and the anti-foamants are depleted by a combination of engine heat and traces of exhaust gas that find their way into the cooling system. To transfer heat from the engine to the radiator, a water pump circulates the coolant through the system. The only remedy for a failed water pump is to replace it. Just be sure of one thing, that the new water pump you install is the correct one. If you replace a small impeller pump with a large impeller pump, the combination of the large impeller and the high drive ratio of the small impeller pump can build enough pressure to cause damage. You see, too much pressure built up in the cooling system may rupture the heater core or cause leaks at the core hole plugs in the block, which I'm sure wouldn't make the owner very happy.
Don't try to correct overheating problems by thinking a larger impeller will increase capacity and aid cooling. Always replace the water pump or pulley with the same kind that was originally installed. The pulley is important because it determines the fan speed and therefore impeller RPM.
Right, Tech. A smaller impeller used to replace a large one isn't good either. The lower capacity may cause overheating on hot days and may not be sufficient to cool the cylinder and exhaust valve areas. Extended operation under these conditions may build enough heat to damage parts of the engine. And as long as we're on the subject of water pumps, let's talk about the fans since they are driven by the water pump pulley. If you're moving fast enough, the ram air through the radiator can dissipate enough heat to handle most of the cooling job. However, at low speeds, a fan is needed to draw air through the radiator to dissipate the heat that has been transferred from the engine. On some engines, the fan is working continuously. On others, the fan is allowed to coast whenever the cooling system doesn't need it. There are a variety of fan and drive combinations available on Chrysler Corporation cars and trucks. Before discussing the fans and drives themselves, let's look at what is done to improve airflow and fan efficiency. A fan shroud, like the one on this model, acts sort of like a suction chamber to draw more air through the entire radiator. It also prevents underhood air from recirculating behind the radiator. The seal between the radiator yoke and the hood also helps the fan shroud prevent recirculation of air behind the radiator. In addition, it forces ram air through the radiator by preventing it from going over the radiator into the engine compartment.
On some cars, you'll even find a seal at the bottom of the radiator for the same purpose. I'm afraid we're out of time on this side. Someone will have to turn the record to the other side before you can hear the rest of Russ's story.
There are two types of fans used on non-air conditioned cars, the 4-blade, which is used on the smaller engines, and the 7-blade, which is used on the larger V8s, and some maximum cooling packages on the smaller engines. Some performance car cooling systems use a fluid, or what is known as a torque control fan drive. It permits use of a high-capacity fan and higher drive ratio to deliver more air when needed, yet has less fan noise and power consumption at high speeds when the extra airflow isn't needed. The fluid fan drive is just that, a fluid coupling drive unit. At high engine speeds, the drive unit starts to slip to limit the speed of the fan and keep the noise level down. Actually, there are two different types of fluid fan drives used on our cars, the straight fluid coupling and a temperature-sensitive fluid coupling. The temperature-sensitive unit also limits top fan speed like the straight fluid coupling. But in addition, it lets the fan coast when the radiator is cold. Here's how it works. There's a thermostatic coil on the front of the coupling that controls the opening and closing of an orifice inside the drive unit. When the coil is cold, the orifice is closed and the fluid coupling is inoperative. When hot coolant starts to flow through the radiator, the air coming through the radiator also warms up. Airflow from the radiator heats the coil, which opens the orifice inside the coupling. The coil will open the orifice at about 165 degrees. When the internal orifice opens, the fluid coupling is supplied with fluid. The fan speed increases with engine speed until it creates enough torque for the fluid coupling to slip and limit the fan speed.
I'd like to point out that there are a variety of different temperature-sensitive drive units with different drive ratios and torque ratings. If you replace one of these units, make sure that you have the right unit for the model you're working on. And whatever you do, never put a thermal-controlled drive unit on any engine that didn't have one in the first place. How about the new flex fan, Russ?
I was just getting to that, Tech. Some models have a fan with flexible blades that takes the place of the fluid drive coupling. It is used primarily on the smaller engine models that are equipped with factory air conditioning. Here's how it works. The flex fans have blades that tend to flatten and change their pitch at high engine speeds.
I have two questions. How and why?
Okay, first, at high speeds, the main thing that causes the fan blade to flatten is centrifugal force. Air pressure against the blade does help. However, it only provides a part of the force to flatten the blade. As the blade flattens and the pitch changes, the fan turns more easily and takes a small load off the engine. At the same time, the fan noise is reduced due to the decreased resistance. Unlike the fluid drive fan, the speed is not limited but increases along with the engine speed. There's one thing to keep in mind if you replace a fan or drive unit. Because of different drive ratios, always use the fan and drive unit specified for that particular cooling system. Switching fans or drive units can cause serious problems. Now, let's take a little closer look at the radiator itself. It's not a very complicated component, but deserves close attention. The radiator is a series of many coolant passages or tubes surrounded by thin metal fins. The coolant flows through the tubes and transfers the heat to the fins, which are in contact with the tubes. The air rushing through the fins in the radiator dissipates the heat from the fins. The coolant passage tubes are small and numerous to speed distribution and heat dissipation, so they must be kept clean for proper coolant circulation. And the best way to keep the radiator clean is to let the coolant do the job for you.
I'm afraid I don't quite understand what you mean, Russ.
If you recall, I said that the antifreeze should be changed every year, preferably in the fall. And the reason was that the rust and foam inhibitors are depleted by a combination of engine heat and traces of contaminants that find their way into the cooling system. And it isn't a good idea to try and strengthen the coolant by adding inhibitors. Many of them contain chemicals that are not compatible and can cause an unfavorable chemical reaction. Actually, the foam and rust inhibitors contained in the ethylene glycol antifreeze are better than the additives on the market. An antifreeze solution that's good to 20 below zero provides more than adequate protection against rust and foaming for approximately 1 year. When you think about it, an annual drain and refill is a pretty cheap way to protect the engine and cooling system from damage.
When the antifreeze is drained for changing, the entire cooling system should be thoroughly flushed with clean water to completely flush all of the old coolant and any contamination from the system before adding new antifreeze. The reference book gives the complete story on the best way to flush the cooling system. The service manual has additional information on cleaning and flushing also. Incidentally, while you're flushing the cooling system, it's a good time to inspect things like the thermostat, radiator cap, and hose connections. You want to tell us about them, Russ?
The pressure vent cap is an essential part of our cooling system. For each pound of pressure applied to the cooling system, the boiling point is raised about 3 degrees. By pressurizing the system, engine operating temperatures and the boiling point of the coolant are both raised. Actually, the pressure vent cap doesn't start to function until the coolant reaches the boiling point and is being turned into steam. Until that point, the cooling system is vented to atmosphere through the cap and the overflow tube, which prevents unnecessary pressurization. When the coolant reaches boiling temperature, the vent valve closes to pressurize the system and raise the boiling point. Otherwise, the cooling system would be venting steam anytime the coolant reached boiling point. The pressure in the cooling system continues to build and thereby prevents the coolant from reaching its boiling point. Now, when pressure in the system builds to between 14 and 17 pounds, it'll unseat the relief valve and allow excess pressure to escape. To check the cap, visually inspect the gaskets and valve to make sure they're not dirty, damaged, or distorted, which will prevent them from seating properly. Use tool C4080 and follow the instructions in the service manual to make sure it operates at the rated pressure. It's also a good idea to check the pressure cap seat in the filler neck of the radiator. Dirt or damage may prevent the cap gasket from sealing properly and maintaining system pressure, or may interfere with the operation of the valve.
I still haven't heard anything about the thermostat.
I purposely saved that for last, Brian. If you recall, I said that the cooling system could more correctly be called an engine temperature regulating system. Remember, it's as important to make sure that the engine does not run too cool as well as too hot. That is the job of the thermostat. The first function it performs is to speed warm-up of the engine, but its main job is to maintain the correct engine operating temperature. Anytime the coolant temperature is below the rating of the thermostat is closed to recirculate the coolant through the bypass without going through the radiator. Now, what the coolant does at this stage is to take heat from the hotter parts of the block and carry it to the cooler areas to establish uniform temperatures. A thermostat that is rated at 185 degrees will start to open when the coolant reaches that temperature and allows some of the coolant to flow through the radiator. When coolant temperature increases about 20 degrees, the thermostat is fully open and does not restrict coolant flow through the radiator. In cold weather, the air rushing through the radiator will lower coolant temperature below the rating of the thermostat. In this case, the thermostat starts to close again and restrict flow to the radiator and raise the temperature of the coolant in the engine. Getting back to your problem, Brian, our thermostats are designed with a fail-safe aspect so that if the thermostat fails, it'll usually stay open rather than closed. Naturally, that would cause overcooling at times rather than overheating. It is possible, however, for the thermostat to fail and to stay in the closed position. If one does fail, make sure that you replace it with one that has the proper rating. Because of engine design changes, most of the thermostats used on the 71s have been dropped 10 degrees down to 185 degrees. You can easily test the thermostat by placing it in water and watching as you heat the water. The service manual has detailed instructions and specifications. Now, let's see if we can find out what's making this baby run hot.
There's one item that Russ didn't cover, and I'm sure that's because it's new for 71 and he probably hasn't come across it in the service manual yet. Some 71s with a larger V8s will have a temperature-operated vacuum bypass valve. The bypass valve advances ignition timing to increase engine idle speed to prevent overheating. At 225 degrees coolant temperature, the bypass valve opens to supply full manifold vacuum rather than spark port vacuum to the distributor advance unit. The increased manifold vacuum advances the ignition timing to reduce the engine heat load on the cooling system. Before I leave, I strongly recommend that you read this month's reference book thoroughly from cover to cover. The film gave you a real good idea of how the cooling system works. The reference book is jam-packed with service tips to keep it working without problems. See you next month.